All right, in this video, we're going to go ahead and finish up with the second day of section 3, 6.3, and we're in example 9. We're going to do a couple more things with the vectors. This example is asking us to find the magnitude and direction angle of the vector v. Find the magnitude and the direction angle. Well, what you're going to see here, some of the things that we're going to be looking at is we're going to be given a vector and we're going to have to decide which quadrant that it's in and be able to find the angle. And since vectors are identified as, let's just say the vector 2, 3. Okay, let's go with vector 2, 3 component form. So we know that vector 2, 3 is in quadrant 1. What we're going to be doing is finding this angle. What's this angle here in quadrant 1 that vector lies at? We're going to be using trig in order to find it. Also, because the 2 right here, this 2 is my x value, which corresponds with the I part of the vector, and then the y value here corresponds to the j part. Remember that x is cosine and y is sine. So you can see here that we're going to start using cosine and sine to also represent some of our vectors. In this first example, A, we've got v equals 8 times the cosine of 135 degrees I plus the sine of 135 degrees j. Well, all of this is right here is the x value and the y value. So what is the cosine? What is the cosine of 135 degrees? Well, 135 degrees, this is in quadrant 2, and it's the reference angle of a 45-degree angle. So the cosine is negative root 2 over 2 I plus the sine is root 2 over 2 j. So this translates into the component form of negative root 2 over 2, positive root 2 over 2. So I know the angle, so my angle theta is 135 degrees. That's given to me. But let's see where the magnitude comes into play. If I want to do the magnitude, then what I need to do is I need to take each of these, square them, and add them together. So if I square the first one, I get a positive 2/4 plus, and if I square the second one, I get a positive 2/4. This is equal to the square root of 4/4, which is the square root of 1, which is 1. Okay, so all of this magnitude here, the magnitude of this vector is 1, and then this 8 out in front is then going to affect the magnitude. So 8 times the 1 is 8. So here's what we've got. We've got the magnitude of vector v is the number in front, which is 8. So see here, this is a unit vector right here. How do I know it's a unit vector? Because I got the magnitude of it to be 1, and then the 8 in front of it is the multiplication of that coefficient to have the magnitude be increased by 8. So there's my solution right there. Magnitude is 8 and the angle was 135. All of that really was going to be able to be given to me from the very beginning of the problem. I just wanted to show you where it comes from. All right, let's look at this one. So 12, 15. Well, we are in quadrant 1. So over 12, up 15. In order for me to find the angle, let's find the angle first. Then I'm going to do tangent of my angle theta equals 15/12. So we're going to do inverse tangent of 15/12. This will give us our angle of theta. And so that comes out to be 51.34 degrees. Okay, and now in order for me to find the magnitude of v would equal the square root of, and see component form is 12/15, so it's the square root of 12 squared plus 15 squared which is equal to the square root of, you got 144 plus 225, which is 369. And that's 3 times the square root of 41. So magnitude 3 square root of 41. Final answer. Magnitude and the direction angle. All right, in example 10, we are asked to find the component form of V with the magnitude and the angle it makes with the positive x-axis. Find a component form of a vector V. Well, here's what I know. I take the magnitude, and I multiply it by the linear combination form. So let's write the magnitude first, 4 square roots of 3. And then I multiply it by the linear combination. If it's an angle at 90 degrees, what I know is that it's cosine of the angle 90, I, plus sine of the angle 90, J. Okay, so this is how we go from an angle to a form of a vector. What is the cosine of 90? This is what we're going to ask ourselves. So 4 square roots of 3 times cosine of 90 is 0i, plus sine of 90 is 1j, multiply by the square root of 4 square roots of 3. So we basically what we're going to be left with is we've got 0 I plus 4 square roots of 3j. So that is the vector 0, 4 square roots of 3 in our component form. All right, let's try another one here. So we've got our magnitude is 3, and we're going to multiply it times 3i plus 4j. But since we are wanting to do a vector in the direction of this, we need to work with an angle here. So what's my theta going to be? My theta at 3, 4 would be inverse tangent of 4/3. Here's where that's coming from. You got over 3 up 4. You got this triangle. So inverse tangent of 4/3 would be the angle theta. Okay. When I finish this out, I get my theta to be equal to, and my theta in this case is equal to 53.1 degrees. So I've got 3 times, and this is where we can go ahead and use our 3 and 4, okay? So we got 3 times 3, 4 over the magnitude. Now my magnitude of my angle let's put this back in here. My magnitude of my angle is going to be the square root of 3 squared and 4 squared, so that's 9 and 16, that's 25. So what we're looking at is 3 times, you got 3/5 and 4/5. So final result would be 9/5 and 12/5. And then this is my angle. So here's the vector, and then here's the angle. And there you have it. All right, looks like we're going to have one more example here to finish the day. Find the component form of the sum of u plus v with magnitude of u being 2 and the magnitude of v being 2, and the direction angles are 30 and 90. Well, if I'm going to find the sum here of these two angles, first I need to find the vectors themselves. So let's do u first. The vector of u equals, the magnitude of it is 2, and the angle would be 30 degrees. So it is, see, these are thetas. It is cosine of 30 I plus sine of 30j. Okay, so there's the angle u. Let's do angle v. Magnitude is 2, so you multiply it 2 times cosine of 90 I plus sine of 90j. Let's go ahead and evaluate both of these. You've got 2 times cosine of 30 degrees is the root 3 over 2 I plus sine of 30j is 1/2 j, and then it's 2 times cosine of 90 is 0I plus sine would be 1j. All right, what we're going to do is I'm going to go ahead and distribute here. You've got 2 times root 3 over 2, so this is my u. So you got root 3I plus j, this is u, plus 0I plus 2j, and that's v. So final form, the square root of 3I plus 3j, and then finally component form would be root 3 comma 3. And there you have it. So what I did here is I found both of those vectors and I wrote them in the direction form, and then I was able to multiply by their magnitude, add them together, and get the component form. All right, here's your next assignment for section 6.3, page 418. You're doing 23 through 43, odd, and 45 through 65, odd. Looks like 23 to 65 odd is fine.